So welcome to the fourth virtual SI session, which is assumably the last one. So we'll try to have the video for this session out by a week before the final. So it does take time to actually have the video editor work on it and just cut out all the unnecessary parts of the clip. And he has his own work schedule as well. So it doesn't come out instantly the next day. So I hope all of you are okay with that. That's just how it's going to be. So we'll go ahead and take a look at the agenda. So the first thing is we're going to be opening up the entire session to some questions, if anybody has any questions at the beginning. And then we're going to take a look at the comparable interface, just some do's and don'ts. And then we'll also have the employee class as an example of how to efficiently implement the compare to method. And then we'll dive into inheritance, just to go over the basics, just making sure everyone has the right approach when it comes to inheritance. So with that said, I guess we could just open it up to questions right now. So if anybody has anything they want to go over that has to do with the last few weeks of class, where we're covering inheritance, interfaces, and whatnot, you can feel free to do so in the chat. Otherwise, I'll give it about a minute. If nobody has anything to say, then we'll just proceed with the SI session, virtual SI session.
All right. So as we mentioned in class, today's last VSI session will mostly aiming towards topics that we went over after the third VSI, and also gearing towards the final exam. So one thing for sure that you guys will need to know or know how to do is how to implement comparable interface and override the compare to method in a way that the prompt is asking you to. So there are a couple scenarios that we will go later. But first of all, we want to go over a little bit about the do and the don'ts. So Mark, you start with the correct form of the do's.
Okay. So the first thing is, the actual first thing you always have to do is to cast first. And what I mean by this is, if you take a look at the compare to method in all of your other implementations of it, you'll notice that it always starts off with something like something like compare to. So you have a bunch of code before this, and then you have compare to, and then you have an object, and you could just call it like other, for example, or other object, or something like that. And it's not really useful to have a type object, because that can be anything at all, right? So and you're assuming that you're just comparing it to the same type as whatever class you have. So I mean, that's not really useful. So that's why we cast first. So we would just say like, okay, my type, my object, or just say other, really. And then you could say like my type and then other object. And then that's just implicitly, well, not implicitly, explicitly casting it to the type that you actually want to work with. So that's what casting first means. Did I miss anything there, Ian?
Can you go over why it's not a good thing to, cast there in the parameter variable?
Oh, so do you mean like right here?
Like for the casting, so you listed as like, object, other. Why can't you say like rectangle, other, object?
So why can't I just omit the parentheses? So I could say like rectangle other equals. So why can't I just say that?
Oh no, I mean like, you know, like in the declaration line, the heading where you say public in compare to parenthesis object, the other object. Why don't you, you know, if you know what you're gonna compare, why don't you just put that specific type in that parameter variable, but
So
you
do you
have to
mean,
cast
do
the
you
later
mean,
words.
so do you mean just this line right here that I'm highlighting right now?
Oh, oops. All right, so you can technically go over the don't for that one.
Okay, so in this case, when you try to do it early, like this, it actually breaks the syntactical setup that Java has for compare to. They've always, so think of it this way: when you have an interface, and Java provides the comparable interface for you already. You can't just say that this is the type inside of the parameter, because if you think about it, this compare to method is getting implemented by all other types of classes, not just like the student class. So if you put this as a type student, then all the other classes are going to treat it like a student first, and they can't cast it, because how do you cast a student into a completely irrelevant type? So it makes more sense to go broad all of the time with just object, and then break it down into smaller classes from there. So it makes more sense to have it as an object, which is like literally every single type, but you just have to cast it afterwards. So that's pretty much the main reason why you don't want to define the type right away. You just want to leave it as an object at first and then cast it, because that's just the way Java set it up. That's the intuition behind their design. So do you think that's enough? Yeah.
So one more question. So let's say I put student and the array or array list that I want to order, let's say first by string and then by int.
Mhm.
If I know all of those objects will be student, then why can I just put student there? Because in the end, student is part of object class. So if I already know what will be in that array or array list before I sort, isn't having student type right here would be enough?
So you're saying like why, if I know everything's going to be student anyways, why don't I just make it like this anyways? Okay. Well, again, that works if your student class does it, right? But remember, when you're defining an interface, so let's say here, like we're making an interface. I'm just gonna call it new comparable, because comparable is actually a native interface that we've always had. So, yep. So I'm gonna call it new comparable, and then what happens is they have a compare to method, right? So it just returns an int, and then if I say student other, then let's think about what this really means. So, well, okay, well, I don't have the student class like in here, so that's why it's throwing that error. But when we do this, we're saying that no matter what class you are, if you implement new comparable, then you're always going to assume it's a student at first. But that doesn't work, because what if they're not a student? What if we made a class called employee, like this, and then we had this one implement the comparable interface? Then that wouldn't work, because if you go here to the employee class, and then you make a compare to method like that, you can't cast student into an employee, because they're not really directly related to one another. So that doesn't work design wise, right? So that's why Java made it so you have to use an object right away. So that's just the way that Java has designed it, in other words. So you always have to just work with an object and then cast it afterwards. So yeah, like, that's kind of the cheap way of answering it, but I'm trying to show why Java has set it up that way. So you always work with an object first, because if you say every single object's a student, then nobody can really use the compare to method unless they're a student. But if you use an object which is more broad, then that's just that works. So that's why design-wise, that's just how Java has implemented it. So that's kind of the intuition of it.
So that is one of them, but there's also another one. So can you open up BlueJ?
All right, sure.
Can you, let's say, create like a dummy student class?
Okay, so student here.
Let's say the student class implements compare new comparable.
Well, why not just use comparable?
Yeah.
Okay, so comparable. So
In this
we're not
class,
using.
yeah.
We're not. Sorry. So we're not using my comparable. We're using the default one of Java. Right.
Okay.
Then what do you want me to write?
Student, the other object. So why wouldn't this work?
So let's say for now, just so we can test it compiles, we'll return 1. So if you take a look, it says that it's not overriding the abstract method compared to. So what does this mean? Well, when we look here, it says student is not abstract and does not override abstract method compared to java.lang.object, meaning that it has to be a type object. And again, that's just how Java has implemented it. Actually, if we take a look, comparable interface Java, then they'll have a method right here. And in other words, this is just a notation saying that it has to be a generic object. So it's a bit confusing with the T. You'll learn about that more in CS46B, but that's just another way of saying it has to be a type object that you define yourself later on. So some of you are asking for the link to the slide, so I'll go ahead and divide it right here. View only, copy. So I posted the link to the slides in the chat, so go ahead and take a look at that when you can. All right, so yeah. Okay, anything else?
I think we can move on to the next one.
To the next bullet point?
Mm-hmm.
Okay, so now there's multiple ways to do the comparable interface, right? So let's say we have a student object and well, okay, it has X, right? But I'm just going to use X because I don't want to like write too many other things. So we're just going to use that for now. So the first thing we always do is cast, right? So student other equals, so then you cast it student. Well, okay, first you have to actually use it as an object. And then cast it. Now let's check if it compiles. Oh yeah, it has to return something. Okay, so then if we wanted to compare X, and let's say X is a string instead of an int, and I guess we'll just say that. then what would happen is you would just simply return other dot, well, actually not other, so it would be this dot x dot compare to, well, you wouldn't even need this actually, so then it would just be compared to other dot x, and that should work. So what's actually happening here when we have compared to right here, and then we're just calling it again right here. So what's actually happening here again?
So there are a lot of questions why are we calling the same method. But in this case, compared to when in line 31, so when it says return x dot compared to other dot x, this compared to method is not the compared to method that we define right here. Mark, can you take a look at the string class?
Okay. So string Java API.
Can you go down to compare to? So you notice string has a compare to methods, and can you go up where it says interface? I think it's up top.
Where?
Up top more.
This is the size that can go.
Yeah, so right here. So all implemented interfaces. So string is a class that also implements the comparable. And in this case, it have specified that this comparable will sort the strings for the string class. So compared to that you're calling, can you go back to BlueJ?
Okay.
That you're calling in this compare to method is actually from the string class. That the string class is already like worked out a code for you, and it already know how to sort letters already, or numbers with letters, or capital letters with lowercase letters. So it's not recalling itself, it's using the compare to method inside the string class. So X is an object of string type that call on the method that it has predefined in its class, and other.x is another string object that should be going in there so that they have something to compare with each other. All right. Am I missing anything?
No, that's pretty much it. Nails it right on the head. Okay, so then the next thing is, how do we compare integers? So if you notice here, we just say, okay, you have integer 1, integer 2. So let's take a look at that. So let's say x was actually an int again. So I guess we'll just say 0 for now, just so we can compile. And what we would end up returning is x minus other dot x. Then would that be it? Let's see here. Would this would this be actually it, Jan? Just as simple as that?
Yes. So why is this working? All right. So x, if you look at it, it says type int, and int is a primitive type, and it's just literally like a number. And so if you take a number and you subtract another number, there are 3 results that you might get. So a positive number, a 0, or a negative number. So do the subtraction between 2 ints will give you the result that you want.
So if this x is less than the other x, and we subtract the other x, then we'll get a negative number.
All right. So let's say X right now is a 5 and order.x is a 2. So if you take 5, you minus 2, you get 3. So you know that this X, the instant X that you have right here will comes after because it is a positive number. Or if it even, then that's another case that you might to have a second test to sort them. But if this X is like a 2 and it minus a 5, you get a negative number. So you know that this X, this instant X comes before order.x.
So some people get confused by this because they think the compare to method is specifically supposed to return -1, 0, or 1. Is that a myth, Yen, or is it actually true that you're supposed to only return -1, 0, or 1?
So as you see in class, we only use -1, 0, or 1. But technically, it can be any negative number, 0, and positive number. The reason why we use -1, 0, and 1 is just for simplicity. I mean, they're all returning the same result. So it doesn't really matter how big or how small a number is, because in the end, it will sort them by positive, 0, or negative. I mean, positive, yeah.
So pretty much the way Java has the compare to method is it compared to when it returns negative, that means this goes before it. If it's positive, this goes after it. And if it's a 0, then it means it doesn't really matter. Just put them arbitrarily. So that's how Java treats it. Now, actually, for some of you who are still confused by this, another alternate way. I actually here we'll cover doubles first, and then I'll show you the alternate way of comparing integers. So now we're going to work with a double. So double x equals 0. So if you look here, you just actually end up using double dot compare, double 1, double 2. Well, but in this case, it's going to be a little bit different. So in this case, it will be x and then other dot x. So just to put a little bit of light on it, so let's take a look here. So double class API Java. I think I'm on the wrong website, but actually here, yeah, let me just go on the actual correct one. So if you take a look, the double class has a static method called compare. And basically, this is a way of saying that Java is trying to make this as painless as possible and just make it so you could just call this method that they gave for you and then just say, okay, put in the first number here, put in the other number here. And it'll just return you exactly what you want. So is it actually just that easy yet, or is there a catch to this?
I think it's just that easy. The trick is, remember, this is a double class. And X right here is a primitive type double. So this is just a primitive type. You cannot. So if you want to use this method, make sure your syntax is correct. You're not using the lowercase letter d. You're using the uppercase letter d of a wrapper class, which that will be going on later. But remember your syntax the correct way. This is like probably the most straightforward way to sort two doubles.
Yeah. And it can get really messy too, because you have to mess with decimals and whatnot. So you don't want to really get into that too much. So you just leave it like that. Now
And
the
also
next.
more. Oh, and also there's a question. So what if I have two ints and I want to use this started method? Can I use it?
So are you saying if I could just do this, and if they were integers? Like,
Oh, no. I mean, if they were both integers, can I still use double dot compared to x, comma, other dot x?
okay, so I've never actually tried that, so I don't actually know. But I will tell you that if they were integers, right? If x was an integer, then there's no need to use the double dot compare when you have another method which is integer dot compare, right? So there was actually two ways to do it. So you can do it like integer dot compare like this, or what we showed you earlier, which is x minus other dot x. Both of these work just fine. They actually do provide the same output in that sense. So if it's easier for you to remember, just use the static method and then just pass it to the integer dot compare. Or if it's easier for you to just say, okay, this minus that, then that's also fine. So either of these would work just fine. Now, Yen, so one person in the chat is also asking, what is other dot x? What does that mean? Like what does that logically mean?
All right. So other dot x. So if you look again, so where is x? The reason why x is the instant variable, all right? So technically there is an invisible dot, this dot. So Mark, can you do this dot in front of x?
Okay.
So usually we don't see it because we already know that x is the instant variable already. So we don't need to say this dot, all right, to specify that this is the instant variable x. So that is usually omit, so it's not as clear. And other dot x is actually the other x from the same type that you're trying to compare. So let's say you had two students with 2x values. The first one will have the one that is for voting this method first is this dot x, and the second one is other dot x. And the reason why we can call other dot x is because this second x right here is riding inside the student class, and so the second x can actually just directly use other dot x to call on the private instant variable. But this is the value of the second student. So this is like really not as straightforward, but let's say you have this compare to method inside a different class called employee, then it would be clear, because the only way that you can access other dot x is by calling like x dot get x or something like that. But because it's inside already, so it's able to access whatever is stored inside a student class, and that includes the private in x. Another way that you can do is Mark, you write like a dummy get x.
Okay, so let's say integer get x, then you just say this, and then you just return x.
Right. So other x is technically equivalent to, can you like comment on the side, say x
What was it?
X equal dot get X. So it's actually X order X. Wait, order dot get X.
Look at that.
Yes. So technically, order dot X is equivalent to order dot get X if they are in a different class by calling on the student methods.
Mhm.
But because they both two same objects in the same student class right now that you try to override the compare to, you can directly access this instance variable. So this is just like a another way to approach that content of the student object or two. Feel free to add anything you are missing.
I think you covered it up. It's just you said a lot, so probably if you wanted to sum it all up and to put it all into one sentence, other.x just means like, okay, so when you're comparing yourself, there's you and then there's the other person, right? So then there's the other person, which you cast right here. Other is right here. So that means other students X, and then this means my X, and I'm also a student. So that's just the idea. So it's my X versus the other student's X. So for the next activity, we have this employee class, and our goal is to have 5 instance variables, which is name, ID, email, salary, and department. So for just clarity, name is a string, right? ID is going to be a integer. Email is going to be a string. Salary is going to be a double. And department is going to be a string. So we have a bunch of strings, an int, and a double. And our goal is to implement the compare to and the comparable interface, and also do the compare to method. And then our order of sorting them is going to be by name, and if that's equal, then by ID, and if that's equal, then by email, and if that's equal, then by salary, and if that's equal, by department. Now, that sounds easy enough if it were like a couple instance variables, but it can get really messy if your logic's all wrong and messy. So there's a way to do this in 11 lines of code. So actually, if all of you could just go ahead and start trying it right now, then that would be good. So here, let me go ahead and make this employee class. And there's one right here. So there's going to be 5 instance variables. So let's take a look at that. So it's going to be a string called name. And then there's going to be a private ID. So int ID, private string email, private, left the caps, private double salary, and a private string department. Yeah, okay. And then that would mean we would have name, well, okay, string name, int ID, string email, double salary, string department. So that's a lot. And
a lot of initialization.
Yep. And then we'll say this dot name equals name. This dot ID equals ID. This dot email equals email. This dot salary equals salary. and this dot department equals department. Okay, good. All right, now we're going to implement the comparable interface. Oh my gosh, comparable. Okay. All right, and then there's the compare to right here. All right, so let's think about this. So we're going to try to do this in 11 lines of code. Brackets don't count. So like what I mean by that is like braces, brackets, parentheses, they don't count as another line of code. So starting from this point, 11 lines of code. So what would be the first line of code, Yin?
Recall the rules that we went over. First thing first, you have to cast. All right. So that when you're trying to sort an array list, it knows that I have to sort it by this object's rule. So the object class that we're trying to sort or compare to is the employee. So we have to cast by employee.
All right, so then that's one line. Okay, so that's the very first step. Now here comes the actual hard part. How should we set up our logic so that we only have 10 more lines of code? So if we think about this, we have 1, 2, 3, 4, 5 instance variables. That means we have 2 lines for each instance variable. So how do we do that? So if we do this, where we say this dot name equals other dot name, and then we do this, and we do something here, and then there will be else, and then here, and then we'll compare it. So we'll say like if this dot name is less than other dot name, and also, by the way, some of you are asking if this dot name could just be name, and it can. So that's the case. So if name equals other, or is less than other dot name, and then we do another else statement here, and then we say, well, okay, hold on. Less than other dot name.
Name is a string object.
Right. So then you would just say, okay, so well, okay, let's say for ID then, because ID is an integer. Oops. ID. So let me just change all this names to ID. So this is what it looks like for numbers. For strings, it's a little bit easier, but yeah. Okay. So immediately, remember, we only have 2 lines of code for each instance variable. This is like 1, 2, 3, 4, 5, 6. And don't forget, like after that, we still have to check the other ones too, right? So there's email, salary, name, and we have to like look at all these other things. And so for 5 instance variables, this is not going to be good. So that doesn't really work. So what is a better way to do this, Yen?
So in the class, one of the way that we went over was return positive, return negative, or return a 0. But with that, we need at least 3 comparison. But there is another comparison where there is only 2 way. So if you guys look at the prompt again, the only time that we need to compare from name, let's say to ID, is when they are equal. So when it's equal, they're,
Do you mean compare them when they're not equal?
hold on a minute.
Okay, sorry.
So in that instant, right, there is either equal or not equal. So that leaves you only with two options. So when it's equal, when you compare them, they have to return a 0. So that means you have to check when it's not equal to 0, or when it's equal to 0. When like you compare the two things and the result returns a 0, then we compare by another attribute within that class. So let's say, can you go back to BlueJ?
Right.
So let's say after you casting, you know this employee object has 5 attributes. And the first thing you want to go by is the name, right?
Mm-hmm.
Okay, so with name, you only want to compare to the next level if one attribute of this, if the first object is equal to the name is attribute of the second object. So if name dot compare to
Equals.
you use compare to is better.
Oh, no, but we got to check if they're equal first, right?
No, if you do compare to, it's gonna return you positive, negative, or 0.
Yeah, but you got to check if name is not equal yet, right? To the other name.
What do you mean? I thought we just getting that
Okay,
integer 0.
you want me to just show my way first, and then you
Sure.
can show yours? Okay. So, so basically, my way works like this. So first, you have to check if your name is not equal to the other name, and it's a string, so we have to do it this way, right? Then so you don't want to return all that stuff right away. You only want to compare if your name is not equal to their name. Otherwise, if they're equal, you pass it down to the next attribute. So let's say they are not equal. Then all you have to do is return name dot compare to other dot name, because it's a string, and that's what we said is good for strings. So then, so if they're not equal, this is what we had checked, right? But if they are equal, then we just pass it to the next attribute, and the next attribute is going to be ID. So this, okay, so actually ID is not equal to other.id. So then we only want to really return something if about the IDs if they're not equal, right? Otherwise, if they are equal, we pass it to the next attribute. So then in this case, it would be return ID minus other.id, as we agreed earlier. So then what's the next attribute? So then in this case, the next attribute is going to be a email. So it's going to be actually quite similar to this right here. And let me just reformat it if that's the case. So instead of name, it would just be email. So let me copy this. Email, email, and email. So then what's the next thing in line? Then we're going to say it's going to be salary. So else if salary is not equal to the other salary. Wait, salary is a double. Oh, I put an else. It's still not safe. Okay. So then this is a double, so we could just use double dot compare and then salary other dot salary. And then the very last thing we need to compare, we don't even have to put an else statement because that's the last thing we check. And that's going to be department. So it's going to be something similar to the string comparison right here. And then it'll be this department. So department right here and other dot department right here. So if we take a look, so this is one line, this is 2, 3, 4, 5, 6, 7, 8, 9. Actually, wow, that was well, actually no, 10 and 11. So just as promised, is done in 11 lines, not counting braces.
So the thing that I mentioned earlier that I would change, but technically it would work the same thing, is in line 39. Instead of saying not name dot equals other name, I would say something like, can you say on the comment?
Okay.
So I would say something like name compared to other dot name. Parenthesis. Can you do like parenthesis around name to other name?
Name to other. There's already a parentheses, right?
I know, like one more.
Okay.
Not equal to 0.
Okay, so it's just.
I would do that format. Wait, can you remove that exclamation mark?
Oh wait, I don't know why I put that there. Okay.
So this basically have the same logic. So if you do name dot compare to other name right here, it will give you like a positive number, a 0, or a negative number. So say it doesn't give you a positive number, I mean a 0, then you just sort it by name. So it will either return you a positive number or a negative number. So it's just like, do I come before or do I come after? That kind of thing. And also you can use like the subtraction for ID. Say ID. Can you do it more like ID minus other ID not equal to 0? But that would basically like the same idea. And that also comes with like double salary or something like that. But the logic is basically the same thing, but we have multiple ways of writing it. Whichever you feel more comfortable.
Okay. So yeah, that's pretty much how it is. Yeah. All right, so that should pretty much solve the problem with minimizing the amount of lines of code that you take for writing the compare to method. It's easier to just go, like check if it's not equal and then do the following return statements for each one that you want. Anyways, so I would test this, but that would take about 10 minutes or so, and we're already about an hour in. So I want to move on to the inheritance one, but so that means you guys are just gonna have to take my trust onto this, but you can try out on your own. you can try it for your assignments even, just like submit it so just go to your compared to assignments and just like submit it, even, you know, just to see if code check would even let it through, and it probably should. I would be very surprised if it didn't. So
I mean, you can still test it on BlueJ, but it takes a lot of writing too.
yeah.
And also know that you can have more than 11 lines, but this is like the most the shortest way that you can have that also give you the right result. So if you're writing more than 11 lines and you feel like you have the same logic as this, don't get like scared. As long as you don't do a bunch of nested loops, and ifs, then and your code doesn't get cluttered in a way, and you know the logic is correct, then possibly your code is also right as well. Just run locally on your BlueJ to see if it gives the result that you wanted or expected.
All right. So with that said, we're going to move on to the next activity. So this one's going to be focused on inheritance. So we're going to have two types of students: the generic student and then a subclass. I think, yeah. So aided student will be the subclass of student. Student will be the superclass of aided student. So the parent's a student and the child is aided student. So the difference between the two is a student just simply has money, and then we have a method, or two methods. One tells you if you have 3,000, then you can afford your tuition, and the other one is get money, which is you just return the amount of money that you have, just showing how much money you have. And then there's aided student. The difference is instead of just an instance variable money, you have two instance variables. There's aid and there's money. And your can afford tuition method is overwritten such that instead of just looking at your money, you look at your aid plus your money and see if that's over 3,000. So let's go ahead and do that. So we have the student class right here, and we're gonna do as it says. So let's see here. So we're gonna have an instance variable called money, and this is gonna be a type double because, well, not the double class, but the double type itself. And what's gonna happen here is because it's money, we have to have the decimal notation. So that's why we're doing that. And then we're just gonna have to say money right here, and we're gonna say this dot money equals money. Then we're just gonna say over here that we have a get money, and it's not gonna return an int, it's gonna return a double, and it's gonna return money. And then the last thing is we don't want to implement comparable. We're just doing an inheritance right now, so no implementation of that stuff. And we're gonna just delete this right here, and we can say public boolean because this returns true or false. And we're just gonna say can afford tuition, and we're just gonna return. So actually, so this is what I see a lot of people do. So they say that there's a, wait, is it boolean? Okay, boolean can afford, and then they say if money is over 3,000, can afford equals true. and then else can afford equals false. And then they just return can afford. But is there a shorter way to say all of this? Yeah. Maybe in one line?
Yes. In how many lines?
In one line?
In one line, yes. So another way that you can do this is, so if you see in the if statement, money greater than 3,000, that expression is a Boolean expression. So it's gonna give you either true or false, right? So another shorter way that you can do is, can you write on another line?
Okay. So I'll just comment all of this actually.
All right.
Edit, comment.
And you can just write return money greater than 3,000.
Yeah.
And why is this working? It's because Boolean is either true or false. And you know that money greater than 3,000 is a Boolean expression which returns clearly a true or a false. So if money, let's say 5,000, and 5,000 is greater than 3,000, so it can give you a true, right? So that is the simplest way that you can write. And it executes the same way that you do for line 29, I believe 29, right? Or so to line 38.
Yep. Okay, so now we just have to make the subclass. So let's go ahead and do that. So we'll have aided student. So this aided student it's going to have everything that, so we'll say extends student, right? Because it's inheriting from it. And now it's going to have an error. What was it?
Art, how many superclass can you extend?
Okay. So for Java, you can only really extend one superclass. And the reason why is because it doesn't, to the Java developers, to their designers, whoever made the API, their idea was, okay, it doesn't make sense to call yourself more than one thing. Like to say that I'm extending from this particular class, it means I'm just like that guy, but I do a few things different. But programmatically, it doesn't make sense to be able to say I'm this guy and I'm also this guy. Like it doesn't make sense to have two different identities and just like do both. And so that's why for in terms of inheritance, which follows and is a relationship, like you can only really extend from one thing. So yeah, the short answer is, okay, you can only extend from one thing.
Move on.
Right. Yeah. So I'm noticing some people in the chat have questions about comparable. We'll cover that in the Q&A. So we'll just save answering those questions for later, just because right now we're talking about inheritance. So please be patient with us, and we'll be able to get to that soon. Okay. So whoa, what did I just click on? Okay, this thing. All right, that was weird. Okay, so so now we have an aided student, which inherits from struggling student and has an extra instance variable called aid. So for sure, we have a private double aid. But do we need to also provide our own money instance variable, just like the student class, Yen? Or do we need this at all?
No, we don't need it at all. So if aided student extended student, that means aided student has everything that student class has, and some additional things within aided student to make it a little more unique. So since that student is aided student superclass, all you just need to do is call on the money instant variable from the superclass instead of initializing new thing. So other way to retrieve that money is you call on the superclass. So can you do super parenthesis money? All right. So that would take care of the money initialization part for aided student. And since A is a new thing that aided student class has, you have to initialize it at a spot instead of calling on the superclass because the superclass doesn't have that, right? And you also have to initialize all the things that you inherit from the superclass, the first line inside your constructor. That's the syntax protocol for that one. And then anything after is from your subclasses.
All right. So we're going to go ahead and move on to the method that we're supposed to overwrite, which is can afford tuition. So I'll do it, Boolean can afford tuition. And we gotta make sure it's spelled exactly the same. So, well, this is employee units. Then, so actually, I'll just go ahead and copy and paste this just to be sure. Okay, it looks about the same. So, well, for now, I'm just going to return true just as a dud. So how should our approach be here? So we want to get some of the aid and the money. So I know for a fact that I could just say return money. Well, no, not return money, return aid, because aid's right here. But how would I get the money? So for now, I'm just going to put in 0 because I don't know what else I could put. But how do I turn the 0 into the money from the student class yen?
All right. Just to be safe, I will put like a parentheses around A and 0 first.
Okay.
And so A, you don't need like a getter class for A because you can technically like get A from the class itself. And the extra step that you have to do is get money from the superclass. So you have to use the gather method that your superclass provided you. So one of the class that it provided you so that you can access it is the get money. So let's go back to aided student. So from that, in order to call that method, you do super dot get money. So what this line does is that it looks at get money from the super class. Since it couldn't find any like get money here, right? But if you do like dot super, it knows that get money is coming from the super class that aided student is inherit from. So it looks specifically at that, and then it adds that number with the A. And now you have your numbers that you can compare with 3,000. You want to add anything else?
So I think you pretty much covered everything there is to get about that. So the only tricky thing about inheritance really is that you know, you gotta remember what your parent has. Like if they already have that method and you don't need to change anything about it, you can always just say super dot whatever that method is, right? And the other thing is you don't want your own instance variables for something that your parent already has. Instead, you should always just call the parent's constructor using super parentheses. And then for your own instance variables, you should just initialize it the normal way.
So,
Go ahead.
so I have a question. So why can't we just do, super dot money? Why did we have to use super dot get money? Why can't we just access the private instant variable instead?
Okay, so let's actually see what happens if we say super dot money. So it says that super dot money has a private access in student. And what that means is if you look here, we set money as private, meaning that other classes can't access it. Because this is technically another class. It's the child, but it's another class. So it doesn't really work quite well. Now, one solution you could do, and I don't recommend this, is to set this to public. But that doesn't really solve the problem, because now yeah, sure, your aided student can access the money. Okay, that's great, but so can everyone else. And that's not very controlled, like anybody can change it. And you don't know what kind of mistakes could happen if someone accidentally changed your money to 0, right? So that's why people make this kind of method right here, public double get money, because this is a way of telling people indirectly with control, like, okay, this is how you can take a look at how much money that I have. Because like if you do it through a method, you can also add other things. Instead of just returning money, maybe you could have like a conditional statement, or you return it in a special way, or you reformat the double into a string because maybe you only want them to use strings, whatever kind of special thing they have. But in other way, this is analogous to saying, like, okay, I can't just randomly grab my parents' money, but I can ask them for it, right? So you just ask them using their method, and you just got to follow by their rules. So that's the idea with object-oriented programming. So that's why it's like that. Anyways, there's a particular question in chat where someone's asking if we're supposed to use @override. So what's that all about? Yeah.
So for inheritance, there are 3 kinds of methods that you can have. So there first inherit methods, new methods, and override methods, or overwritten also. So new methods that are coming from the subclass that the parent class, that the superclass doesn't have. Inherit methods is methods that you inherit from your superclass that you don't want to change in your subclass.
Mm-hmm.
And override methods are methods that you inherit, but you want to change it a little bit. So, and that is the case with can afford tuition. Tuition is basically almost half, the same thing as your can afford tuition in your student class. But there is something extra, which is the super dot, which is the A. So this is like we change a little bit, but part of it still remain the same. So that is an example of an override method. And there is another method that we use in this case, but we didn't really display, which is the get money. Get money is an inherit method that we didn't change at all. We just literally call on the superclass. And the thing that we didn't show is new methods, but that is whatever new methods that you want to add to aid a student.
Okay. So with that said, are we pretty much done with this activity yet?